So let's take a look at another trig equation. So find all solutions of the equation in the interval from 0 to 2 pi. And we've got this equation. So cosine 6 theta, cosine 2 theta, plus sine 6 theta, sine 2 theta equals -1. Okay, so when I look at the left side of the equation, what pops into my head are the angle sum and angle difference identities. So I have those brought up over here. If you think about it, let's focus on the right side here. So we've got, notice, cosine, cosine, addition, sine, sine. So let's look. So cosine, cosine, addition, sine, sine. This last cosine one right here. So that's actually an angle difference. So we can think of that as cosine of the difference between the two angles, 6 theta and 2 theta. So using that identity, I am going to make a substitution. So I am going to substitute for this left side, right, that really I'm looking at this 6 theta is angle A and this 2 theta is angle B. So again, if you take another look at this, so this is cosine A, cosine B. So cosine A, cosine B plus sine A, sine B. So I know that I can rewrite that as cosine of A minus B. So really that left side of the equation, I'm going to replace with cosine of 6 theta minus 2 theta equals -1. Okay, so now once I do that, I'm going to subtract 6 theta minus 2 theta. So that gives me cosine of 4 theta is equal to -1. So now I'm going to solve for 4 theta. So in my head, I'm thinking, okay, cosine of what equals -1? Well, let's think about, okay, I'm kind of thinking about unit circle and what would correspond to this point, which would be -1, 0, right? We know that's cosine theta, sine theta. So cosine of pi is equal to -1. So that means that I can say, okay, 4 theta is equal to pi. And so since we're solving for this angle where we're multiplying 4 to it, so like we've looked at examples like this before, I want to know what theta equals, not 4 theta equals. So since I'm solving on this interval from 0 to 2 pi, I really need to think about multiples here. So I know from here I can continue, to add 2 pi. Right, so this is really 4 theta is equal to pi plus some multiple of 2 pi, or 2k pi, where k is an integer. So dividing everything by 4 to get theta by itself, theta is equal to pi over 4 plus, I'm going to reduce, so this would be k pi over 2. So now I want to think about, okay, so how many times can I add a multiple of pi over 2 to get a solution that's in between 0 and 2 pi? So let's start with, with k equals 0. So of course, that's just going to give us theta is equal to pi over 4. So now if k is equal to 1, then theta is equal to pi over 4 plus 1 times pi over 2. So remember, we need a common denominator. So I'm going to look at this as pi over 4 plus multiplying by 2 over 2. That would be 2 pi over 4, or 3 pi over 4. And 3 pi over 4 is still less than pi over 2, so that is a solution I would include. So if k is equal to 2, then theta is equal to pi over 4 plus 2 times pi over 2. So that actually just reduces to pi. So pi over 4 plus, we need a common denominator, so that would be 4 pi over 4. So we would have 5 pi over 4. Again, less than 2 pi, so we're going to keep going. So what if k is equal to 3? Then we would have theta is equal to pi over 4 plus 3 times pi over 2. Common denominator, multiply by 2 over 2. So this is pi over 4 plus 6 pi over 4. So that's 7 pi over 4. Still less than 2 pi, right? Because 2 pi would be 8 pi over 4. And then if we think of one more, we're probably going to be too big, but let's take a look at the math. So if k is equal to 4, we would have theta is equal to pi over 4 plus 4 times pi over 4, or pi over 2, excuse me. Pi over 2, which would reduce to 2 pi. So if I add 2 pi to pi over 4, surely I will be beyond 2 pi. So that's where we would stop. So I have several solutions. So let's go back and take a closer look at this. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 are my solutions.